Good afternoon, everybody. My name is Rudy Shankar with the BI University, and this is the fifth uh, talk in our seminar series for spring on AI and power. And I think this paper captures that sentiment very well. Power for AI and AI for power. And the speaker, Mark McGranaghan from EPRI, Electric Power Research Institute, will be delivering this talk. Now, Mark is right now, it's truly afternoon for him because he's in Ireland, and I know there's 4 or 5 hour difference, but it's probably quitting time for you. And thank you for staying for an extra 90 minutes for the seminar, Mark. Mark is an old colleague of mine and is one of the nicest guys you could meet. And he was a fellow for EPRI and based in Dublin, Ireland. And he provides technical and strategic input and guidance across the organization and for the electric utility industry around the world. He has authored more than 70 technical papers and articles on topics ranging from power quality to insulation coordination and extra high voltage systems. He's been a leader in the development of smart grids for the last 20 years. He's an IEEE Fellow and in 2014 received the Charles Trogius Steinmetz Award for the expertise and dedication to power engineering standards development. He's co-author of the book Electric Power Systems Quality, now in its third edition, the premier textbook on power quality and compatibility since its initial release in 1996. Mark has a Bachelor of Science and Master of Science in Electrical Engineering from the University of Toledo. He has a Master of Business Administration degree from the University of Pittsburgh. Mark, the floor is yours.
That's great. Really appreciate this opportunity, Rudy. Rudy and I go back a long way, worked together for a long time, so he doesn't have to twist my arm too much to take part in his seminar. This is my second time. A number of years ago, I did another presentation, so it's always great, and I appreciate the opportunity. We're going to talk about the title of Power for AI and AI for Power kind of says it all. We're gonna talk about the developing AI infrastructure and what that means to the power grid in terms of being able to supply this increased demand associated with that infrastructure. And that's the first part. And then we'll turn around and talk about how we can use that infrastructure to operate the plan and operate the power system and maintain it more effectively and efficiently. So that's the two parts to this presentation. The structure is we'll kind of go through the presentation material, and we have a good half hour for questions and discussion at the end. So hang on, keep your questions in mind as we go through. If something's really burning on your mind as we're talking, get Rudy's attention. I can't see the chat, and we'll answer it at that time as well. You're probably mostly familiar with EPRI. EPRI is a large nonprofit research organization based in the United States. But one of the things that I'm most excited about where EPRI's headed and our long-term strategy is this aspect of global engagement and really being a global company. I'm part of a subsidiary that we call EPRI Europe. There's about 50 of us in Europe. We participate in research projects. We're in, I think, about 14 Horizon Europe projects, research projects here in Europe. We have a team in the Middle East, mostly in the UAE, who I'm praying for at the moment. I hope they're all safe. But our global agenda and our global participation is very exciting, and I think that's a win-win for all of our members in the U.S. as well as we learn from developments and research that's going on around the world, bring that to the table as part of our collaborative research. So I hope many of you are already engaged with EPRI and in this area of artificial intelligence, it's even more important that we work together as an industry to both be able to supply this infrastructure and take advantage of it in a safe and secure way. So that's a little bit of background on EPRI. Feel free to keep in mind some questions about EPRI as we finish up as well. But we're going to jump into just this craziness that's going on of increased demand and investment in infrastructure to support this artificial intelligence expansion and development. And the numbers are mind-boggling. In terms of the growth in demand, and especially the dollar investment numbers are crazy. I'm here in Ireland where data centers are already 22% of the load in Ireland. So in the US and actually in the rest of Europe, the data centers are less than 5% of the load. But here in Ireland, it's been kind of the data center headquarters of Europe for a long time. So we're very familiar with this trend, and it's just as much of an issue here in Ireland as it is in the States. And we'll mention that in a later slide as well. So a lot of things going on. Um, and it varies as we go state to state, as we'll see in just a minute in terms of what those investment numbers look like. Our boss, Arshad Mansour, likes to refer back to this technical paper from 2017 that was written by a bunch of the um, Google research folks and published, for everyone to read, and really started the trend towards the um, transformer type of artificial intelligence development with tokens and the ability, the concept that instead of just looking for what word followed another word and producing text in that way, the concept of a transformer um, was identified and was characterized where you looked at a word in the context of a long string of words and the more you could relate that word to lots of other parts of that string, the better you could reproduce actual um, thought and cohesive responses to queries to the artificial intelligence engine. So this paper it all kind of got going in 2017 where really we're developing knowledge rather than just simple relationships. And that's what these data centers that we develop now are really, we like to call them knowledge factories, and we have to supply the electricity to supply these knowledge factories. That you can see at just in that around that time frame of 2017 when that paper was written, that's the first time that the we used this transformer uh, approach to transformer technology for the artificial intelligence development and the the required computing power to process these long strings with the tokens within those strings became much greater and really started to take off and the value of the resulting AI tools increased dramatically as well. And so it things really took off after that 2017, and they're still going in that direction. Are you still seeing the screen that
Yeah,
I'm on?
yeah, we're seeing it, Mark, but it's not in slideshow mode. It went back to
It's
okay. You're back. You're okay. You're good.
okay. This is slides on. Okay,
Yeah.
good. So it's taken off, and the result is just crazy development of the AI tools. Even we just in the period, say in the last 5 years, and the iterations on the AI tools that have resulted from this technology where we in terms of the intelligence level of the tools, we're talking about, the common sense of a house cat in 2020 to what a 4-year-old might be able to respond in 2022 to now AI tools basically on the benchmarks that are out there, being able to perform at the level of basically having a PhD student at your side. So it's a little scary for all of us, but that's where already these tools are at, and each iteration on the tools that are released is dramatically more powerful than the previous iteration. So they're really starting to reach the level of performance that's required for the vision that is justifying this investment. And that's really one of the things that we have to look at is where for these trillions of dollars that are being invested in data centers and infrastructure to support these artificial intelligence tools, where's the return going to come from? Where's the money going to come from that justifies these investments and provides the return to these organizations? And we like to characterize that, that value proposition in three different waves. We're definitely in the middle of what we call knowledge AI, which is being able to do advanced queries to get answers to questions that based on having a knowledge base of everything that's out there on the internet and getting intelligent answers to those questions and being able to use that to generate reports and legal documents and whatever much more efficiently. And that's a big that's a big potential revenue streams in and of itself, but it doesn't justify these investments that are being made in the infrastructure. The real value comes when these tools actually become workers, when they actually can interact when as you send an email or send a query and the agent responds and communicates to other people and other agents that are part of your workforce, and it's a communication and an interactive process that that occurs that's much more complicated than just answering a query and producing a document. And we are basically there. There's companies that are already offering the agents that are sold as workers for the legal profession or for engineers or for various kinds of office tasks. And this, the white collar portion of the GPT in the world is about $30 trillion. So if you think of even 5 to 10% of that being able to be replaced with artificial intelligence, then we're talking, you know, 10 trillion, 5 to 10 trillion dollars in potential revenue opportunities. So now we're starting to see the return that justifies the investments that we're seeing. And of course, as we get to actually being able to do physical tasks that are part of our industrial process right now with robots, and then the floodgates are open in terms of the value proposition for these tools, and we're on the verge of that as well in terms of being able to have intelligent robotics that can handle physical tasks that are it's a little bit more difficult for the AI tools to to handle. So that's kind of where we're going, and that's why everyone's rushing to get in the lead and make these investments. And we've seen this before. We've seen this before. You can think back even recently, you could go back to the other major revolutions like the printing press and like when we, first started writing in general and how it impacted society. But you think about the investments in fiber and communication infrastructure and how you know, we completely overinvested and there were companies that went out of business, but then the value proposition hit in terms of the value of that fiber infrastructure and everyone started to cash in and take advantage of it. The same thing happened with the internet itself and web-based services and the internet as the foundation for interaction and social and services in general. And again, it took some time before the returns on the investment kicked in, but then became part of everyone's life and really needed to be part of that environment. And those are the companies that are making the money now. And AI infrastructure really is the same and probably will go through the same process of some kind of a shakeout in the industry before the really high payoffs and the kind of foundation of future society aspects of what this technology is. So the you can think about it in those terms and understand why we're seeing these investments that we're seeing. And it's not just flops. It's not just computational power that we're talking about. It is electricity. This infrastructure needs electricity to function, and really, the electric power generation and electric power grid infrastructure is the primary holdup in terms of just how fast we can implement this artificial intelligence infrastructure. It's getting the electricity that's needed, and that's where a lot of the creativity and innovation from the generation, storage, and continued improvements in efficiency as well are happening to supply this infrastructure. So we have to, it's the challenge that we face as an industry, providing the capacity to um, handle this foundation of future society. I wanted to highlight a new report that just came out. I think came out just last Friday, if I'm not mistaken. It definitely was last week sometime. And but it's we had one in 2024 that had projections of the um, capacity to the grid and generation capacity needed to power this AI infrastructure. We have an updated report that just came out, and it really looks at it's U.S. focused, so it's not a global projection. There's other documents out there that look at also look at the global projections for this infrastructure, but it looks at kind of state by state um, projections and plans of the large tech companies in terms of AI infrastructure investment and projects that have been started, projects that are planned, looking at chip sale projections, and comes up with projections for each state in terms of the grid and generation capacity requirements to supply this the data center load. And these this chart of the U.S. is has three um, items shown for each state, kind of the capacity requirements from our 2024 study, and then the updated projections for 2026. I'm sorry, 2021 and 2024. And then the orange band is the range of projections in our updated report that just came out. And the the size of the circle is the amount of capacity that's required in gigawatts. And you can see it, there's a scale over on the right that illustrates that, there's the larger circles are more than 10 gigawatts in some of the states like Texas and Virginia and Illinois and Ohio that just and Georgia are some of the example states that have very, very high projections for new data centers and just based on what's happening. These projections are 60% higher than they were in 2024, so we can see the direction that this is going in terms of um, the requirements that are out there. But it's not just data centers. We got to keep that in mind when we look at the grid requirements and infrastructure. Really, especially here in Europe, but in the US as well, we're electrifying everything. We're electrifying transportation. We're electrifying heat. In the US, we have a lot of air conditioning load. We're going to talk about that in a minute. But so when we electrify heat, it really just it it just lines up with our air conditioning load in the summer and heating load in the winter. So that doesn't change much. But the electric transportation does change a lot, and it's likely that the transportation will be even a bigger load than data center load over time. But for right now, this data center load and the increases in the data center load is the driver for increased capacity that's required of the grid. While because the process of electrifying transportation is happening at a slower rate. But it is very important to keep the kind of the entire increased capacity requirements in mind as we go forward. But we've been through it. And that's where I mentioned air conditioning, just to let the cat out of the bag ahead of time in terms of the answer to the question, what the largest electric demand driver is in the US, it's air conditioning. It's, Carrier is 100 gigawatts of load for Carrier air conditioning, Daikin 66 gigawatts, Train, and we expanded the grid, at a very fast rate back in the late 50s and the 60s to support this growth in air conditioning load. We were able to do that. We were able to keep up with the increased demand from air conditioning by expanding the grid and the generation at the time. And that's what we have to do for artificial intelligence is put our thinking hats on and figure out how to supply this increased load. And one of the ways that we're going to do that is flexibility. Take better advantage of the infrastructure that we have. And there's a study that came out of the Nicholas Institute at Duke looking at some of the capacity that can be released just by allowing curtailment of loads for a very small percentage of the time. And from a quarter of a percent to 1% curtailment at the times when the system is at an absolute peak can release that, allow us to implement more capacity, more load for the rest of the time. If we can just make sure that we don't add on at those very worst times, those peak times, there's a tremendous potential available to add more load as long as it's not added right at the peak of the electric system. And the amount of benefit from that depends on the particular reliability area or balancing area. But it's a huge opportunity everywhere. So flexibility is going to be a key aspect of supplying this data center load as we go forward. And so with that, I just introduce a project that we have at EPRI called DC Flex, Data Center Flexibility, um, to really look at innovations that are required in this space, from being able to get flexibility from the data centers themselves, what kind of utility programs can encourage and result in this kind of flexibility? How can we get this into our grid planning process to manage that flexibility and take advantage of it? And those are all aspects of this DC Flex project, and it is a global initiative. We have demonstrations in the Middle East, we have demonstrations in the UK, demonstrations in the US to look at the technologies to make data centers flexible, take advantage of flexibility from other things as well. So this is an important initiative as we go forward. And one of the things that it's important both in this initiative and in our work to figure out how to take advantage of artificial intelligence as well is having all the stakeholders at the table. Not just the utilities telling these folks what to do, but having Google and Meta and the hyperscalers uh, participate in these demonstrations and be willing to fund the technologies that we're talking about, the data center developers, the providers of the technology that we might use to get that flexibility. If we're going to use UPSs in a different way, or we're going to use energy storage in a special way, we need those folks at the table for initiatives like this so we can move some of these technologies from demonstrations and concepts to actual deployment. And so I'm very excited about this project as we go forward at EPRI. One of the things that we're doing in the project is coming up with a standard way to categorize data centers and the technologies in the data centers. We call it a large load classification system for its ability to provide flexibility and also be a better citizen on the grid. We talk about at the highest level, an A classification. We haven't come up with the actual terminology yet. This is in progress as part of the project, but does it support the grid during disturbances? Can it can it when there's outages, is it ability to continue to supply itself? Does it have flexibility when the grid is operating at its peak levels? Um, can it provide long-term flexibility, or can it provide very fast response for frequency response? And does it actually look like a dispatchable capacity? So those are some of the things that we're looking for in the flex in the classification system. But this by having a facility and understanding what its capabilities are, we'll be able to plan for that as part of the grid more effectively. So that's one important aspect that's going on. And we also it's not just the capacity of the data centers and conventional flexibility, but we have to look at some of the unique characteristics of this increasing load level. One aspect on the right-hand side of this slide is the ability of data centers to ride through momentary disturbances on the grid. This we had a couple events like this in Ireland as well, where there's a fault on the transmission system in another part of Ireland, and that fault results in a voltage sag in the Dublin area. That voltage sag causes all the data centers in the Dublin area, which is over a gigawatt of load on a 5 gigawatt system, and all of them to trip at the same time. So that's bigger than any power plant that we have. So it becomes our critical reliability consideration is not having all the data centers trip at the same time due to something that's not even an interruption to the data center. So that's something that we want to look at. Does it require a different way for the UPSs to operate in the data centers and ride through those disturbances? Can we take advantage of energy storage? So that's a very important consideration. We've had similar events in Virginia as well that article is talking about. The other thing is these data centers for training AI do not behave like we like to think of data centers as a nice constant 24-hour load. It's a beautiful load. It's on all the time. It's processing, it's storing people's photos, and it's responding to queries. And no, that's not the way these training data centers work. There's a very they go through different modes in the training process that have different load levels associated with them, and it can be actually a very dynamic load, and we have to be able to deal with that in some way. That's a challenge for we could take advantage of, we're looking at energy storage options to be able to deal with that and make the load look like a more constant, a better load for the grid. Of course, we've been through this as designers and on power grids for a long time with things like arc furnaces and stuff. So we understand what the concerns are of loads like this, but now we have to deal with it with data centers as well. So that's interesting. So what kind of innovative approaches are being taken to make sure that we can supply these data centers, that there's generation available, that the grid is available, and we're seeing regulatory considerations, we're seeing unique contract approaches to do this, utilities partnering with infrastructure companies. And of course, you're seeing lots of discussion about the impact of data centers on ratepayers with potential investments in infrastructure to support data centers, resulting in potential increased cost to ratepayers in general. So we have regulators that are looking at new approaches that encourage or require the data centers to make sure that they take on the investment requirements to support their data center and kind of have a ratepayer residential ratepayer protection or ratepayer protection associated with those. And Texas has some particularly um, uh, interesting large load rules under this Texas SB 6 for making sure that the data centers carry the costs associated with doing their build outs. And we're seeing some interesting approaches to that around the world as well. And I'll mention the Ireland situation in a minute as well. Also, we have a large load, the regulation that was published at the end of last year in Ireland as well, which at least lays the groundwork for data centers being able to continue to expand here as well. So a lot going on in terms of regulatory guidance. This DOE 403 rule is kind of a landmark rule, and that gives FERC the authority to regulate and standardize these large load interconnections. So we're going to see a lot of development in this space around, making sure that we can supply these data centers, but also making sure that the data centers don't, result in impacts to ratepayers and approaches for doing the coordination and studies to evaluate the impact of the data centers on the grid and on other customers and creating a pathway for data centers to actually get their projects off the ground with by providing flexibility, by meeting the financial requirements and everything else. So this is something to keep your eye on. I think we have the president is made this one of his items that he's been talking about at the State of the Union and he's got an announcement coming out this week that along these lines that um, probably will just reinforce some of the systems and approaches that are already being taken to make sure that ratepayers are not impacted by these data centers, that they have their own um, capacity resources identified and even if it's whether it's behind the meter or integrated with the grid, it's that's not an impact to everyone else. So I mentioned Ireland as one example of these. It's called a large energy users connection policy, but some of our really large users, like in the pharmaceutical industry, are not under this. they can go on. They're operating the way they already do. It really is focused on data centers. It requires that they have generation and storage capacity that matches their required maximum demand. So they they have to, and that has to be close to where they are. It doesn't have to be on site, but it has to not result in a big additional demand for infrastructure investment in the grid. They have to identify new renewable energy implementation somewhere in Ireland as part of that. That also matches that capacity. So they need to have the capacity close to them, and they also have to make sure that overall in Ireland that we're continuing to expand our renewable investment accordingly. They have to work with our air grid and ESB in terms of locational issues and hosting capacity capabilities and have all stakeholders involved. And it's up to EirGrid and ESB have to have their connection process basically associated with this rule. They need to publish that by the end of this month right now. So they're very aggressively working through that as we speak. So this is an example of a large energy user connection policy, which is really along the lines of what we're seeing in Texas and other places for the most part. And we are seeing a lot of things in the U.S. around taking advantage of fossil fuels to supply this data center load, at least in the short term. Gas is the resource of choice. There's no question about that for a lot of these data centers, and that is really a valuable, flexible resource anyway for the grid as we integrate more renewables. So that becomes a real positive. But in the longer term, there's these data centers and the companies that are building and operating these data centers are willing to invest in new technology, and they are becoming the drivers of the technologies that will be the basis of accelerating our low carbon objectives as well over time, whether it's advanced nuclear and nuclear in general, long duration energy storage, carbon removal technologies, energy storage technologies in general, power electronics to integrate with the grid, the to meet the power quality requirements. These are the most advanced investments in the industry, and taking advantage of the fact that the funding is available to actually, uh, use these technologies and advance the technology is going to make them commercially available for all, applications in the long run. So having this investment to move from prototype to real application for these technologies is a huge long-term benefit of these AI um, data centers. So keep that in mind. So that's some thinking around how we're going to supply these at, short-term challenges, but in the long run, these investments can really help us with the electric infrastructure that's going to be required to meet all of our electrification goals and supply a system, of the future that takes advantage of these knowledge factories. And with that, I'm going to move into part two. It's not as long a part, don't worry, in terms of where we are in terms of actually using these knowledge factories, using these AI technologies for the power system itself. And this is not new. We've been using artificial intelligence, we've been using machine learning, neural networks, um, deep learning approaches for a long time to do applications in society in general and in the power system in particular. But generative AI is a new animal that can complement these other artificial intelligence technologies, and it really expands the applications that are available to us. We started a consortium called the Open Power AI Consortium. If your organization is not in, get in, be part of it. It doesn't cost anything. Um, it includes all the stakeholders that are involved, the the artificial intelligence companies, the startup companies that are developing artificial intelligence applications, utilities themselves, um, the big vendors that are selling software and applications that help you manage the grid in general, and the resources that supply the loads on our grid. So this is this is a very important group that we can take advantage of, that has kind of three main goals associated with it. One is identifying the applications and providing some foundational models to help in applying those applications. So that's kind of identifying the use cases, having a sandbox for trying those use cases out in a safe and secure way, and then finally sharing across the industry experience with applying some of these technologies. So that's what the Open Power AI Consortium is about. If you Google it, you'll find the website for it, and at the end of that website is an application to be part of it. And we want as many people as we can in. We have biweekly calls around use cases is a big focus right now, identifying and prioritizing what those use cases are. So think about that. It's a big list. This slide is an impossible one to keep up with because the members expands every week, but it's important to realize that it is the range of stakeholders that are part of this consortium as we work on identifying the applications and actually trying them out on the grid. So that's something to keep in mind. What's involved in actually deploying the AI technology, and these are, I think, some of the important steps in the process. Data, 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 data. Getting your data organized, having a data infrastructure and platform that makes the data available to applications, security of the data. So data security and governance is a huge factor. Looking at policies in the company and regulations for using artificial intelligence, using these applications, and coming up with coherent approaches for policy, but also at the same time really encouraging folks to use these technologies. We have to infrastructure is what we've been talking about in the whole first half of this talk. We need the infrastructure to support these applications. That may involve infrastructure in your own company. If you want to apply some of these AI technologies on site rather than in the cloud, then you need the infrastructure to support it locally as well. So that's going to be one of the decision points that's critical for a lot of companies. And then actually training models, using those models, validating their performance with experts, and continuing to manage the training of those models. And then finally, it becomes a skills issue and a staff issue, and bringing everyone up to speed. Um, I know within our own company at EPRI, we have the whole range of expertise in terms of using these AI tools, and the ones that are most advanced, trying to bring us laggards along and help train us. And we have in small groups sharing sessions of best practices and lessons learned, and trying to have as much communication as possible about what we're learning as folks are trying things out. And the skills aspect is going to be a very important one as we go forward. I mentioned data. We have a white paper that came out of the Open Power AI Consortium on the data readiness and kind of getting your data infrastructure in place and factors that affect that and approaches for doing that. Let's see, I'll go back here for a second. And it really does. It is important for it to be executive level attention and decision making and encouragement to put the data infrastructure and strategy in place and kind of get the whole organization behind it so that you can take advantage of it. It needs to be a priority from the top down, and that's probably one thing that's worth keeping in mind. I'm going to use this slide. I was at the NLIT conference in Bilbao last November, and I was running an AI session there, and one of the presenters was providing a utility perspective. This is EDP in Portugal. Um, Louis Cunha there is one of the experts. He's written a book also on taking advantage of AI. That's an excellent resource. But this is what they refer to as their seven big bets um, around data and AI acceleration at EDP to maximize the value to the company. And I thought this was really well thought out in terms of it's kind of the prioritization process of use cases that we're going through in the Open Power AI consortium right now, and they've done it for ADP and are getting on with it in terms of these are things that they see, that they can take advantage of basically now. Forecasting. Forecasting is a huge issue, and weather is a critical part of that. Um, Asset performance optimization, a big area. We see that at EPRI as well. Predictive analytics and remote operation of those assets. The as we're talking about putting in new generation capacity, what types of plants, where to put them, um, reducing the engineering involved, allocating the CapEx to make those investments, a lot of AI support in those areas, taking into account data center infrastructure as well as electrification of the grid overall. Managing field work, huge opportunity as we mentioned the whole aspect of automated workforce and managing field work. Managing field work comes right into play there. The customer interface is already in every business being taken over by artificial intelligence, and the electric infrastructure and electric companies no difference there. The productivity of teams um, is in terms of all types of operations absolutely critical. And then finally, just personal productivity everywhere is a focus. So I thought those were seven really important categories. I think that's very well thought out. They implemented this Mind for X concept of having agents for lots of tasks. This goes along with that bet number six of really automating operations and having lots of agents helping with all the different aspects of operations, whether it's legal or other office functions or employee support functions or policy development, um, the market research, just whatever they can think of that they want to have a agent mind that's working with employees to perform that. And they're already doing this. This is in place and continually being improved as new versions of these AI systems become available. These agents just become better and better. So, good example of taking advantage of AI in the industry, and that's where the entire industry is going in terms of taking advantage of generative AI, combining the kind of the natural functions of generative AI, dealing with language and knowledge retrieval, along with data that we have for our industry, time series data, um, for vision data or images for various tasks, whether it's satellite imagery or LiDAR or drone footage, taking advantage of that along with the natural language processing results in the ability to have lots of new applications. I wanted to come back to flexibility. I think AI can really help us in terms of identifying where the flexibility is, the characteristics of the flexibility. We would just think of electric transportation as one example resource that's so flexible and has so much potential to be part of the way that we manage the grid. But there's so much intelligence that's needed in terms of forecasting and managing that resource in combination with customer preferences and a lot to be learned there, but huge potential benefit to the grid, just as one example. A few examples I was going to throw out that we're working on um, that just are examples of where AI can provide some real benefit. One of them is in managing gas turbines, essentially having a digital twin type of approach, but being able to ask questions or look at potential problems and issues with gas turbines and using a combination of the large language models along with data that we have about specifically about gas turbine performance and failures and characteristics from past machines and past events, along with data that you might have internally about that specific machine, and combining that with the results of the large language models and the rest of the information that's out there to feed into this expert model that can provide a more advanced response than would be available than just using the chatbot agent on its own. So, as an example of trying to do that, a lot of applications where we start to get into this robotics aspect, and at least for inspection and drones, where we can go places where we don't want humans to go anyway. And our nuclear sector is looking at this. I've been looking at this for a long time, actually, in terms of uh, keeping track of storage of nuclear materials and characteristics, and even being able to measure important quantities and report on those without people actually having any danger of being exposed to radiation. That's one example. Hard to get to places, inspecting dams, inspecting the internals of containers and storage containers. Lots of applications that involve taking advantage of both robotics and intelligence to reduce danger and issues associated with humans doing tasks. So those important areas to keep in mind. The whole area of satellite imagery is a huge potential area for artificial intelligence. Um, Whether it's satellite imagery or um, LiDAR created imagery or drones created imagery, by combining some of these different approaches to getting the images and analyzing that data, we can verify the accuracy of our GIS systems. We can combine our asset infrastructure with vegetation infrastructure, with other community-based infrastructure that could be important, and develop improved maintenance approaches, especially vegetation. I mean, a lot of the value proposition that's happening right now is a lot of startup companies in this space looking at identification of dangerous trees that could be a problem, um, and reducing the cost by targeting maintenance requirements to where the most value is, and but increasing the value of that maintenance at the same time. So a lot of potential in satellite imagery as we go forward. We can improve that with inspections by taking advantage of imagery, LiDAR and other types of imagery of our assets, building those databases. That will just increase the learning of these artificial intelligence systems even more, and increase the value that we get from using them to identify issues automatically, uh, improve reliability, reduce outages. Lot of activity in that space. Again, an area where a lot of startup companies are proposing applications that are already in place. We've been developing libraries of these images. A lot of those are curated libraries, which we have images of insulators that have damage, and we know what that damage is, and we can train artificial intelligence systems to take advantage of that and be much more accurate in their problem analysis as they process imagery data from drones and other types of image collection. The range of applications is crazy. You know, don't try to read this. It's just to illustrate that we have so many use cases that we're identifying and characterizing in all aspects of the planning, operation, design of the power system. Each of the applications that we have in our use case repository in Open Power AI has a short description along with a value proposition um, of those use cases. We're just in the process of going through a large survey of Open Power AI members to kind of prioritize what we should be working on as a collaboration in terms of these use cases and how we can accelerate the adoption of the tools and the agents to facilitate some of these use cases. Improved asset models. We have we recently released a tool called Alarma. It's a open source tool for processing alarms in an operations center and being able to prioritize those alarms for the operator and so that he doesn't get bombarded with so many um, alarms that are not critical and really focuses on the ones that are most important. That's a good example. Categorizing faults and the causes of faults, obviously one that we've been thinking about for a long time as well. So a lot of applications out there. There's no way in this webcast or this seminar that we're gonna, we just want to look at it at a high level for today, but it is worth kind of digging into these use cases one by one, looking where we are in the industry, what's needed, what's already available, how can we take advantage of it, what are the data requirements to implement that, what are the skills required, do we need to change our staff requirements, and so on. So a lot of potential there as we go forward. So we call this the knowledge revolution, and we think it could be even bigger than the industrial revolution in terms of the future of society and definitely the future of our industry. So really appreciate the opportunity. Let's see what questions people have or discussion or your own thoughts on the topic will be very interesting as we go forward, Rudy.
Well, it's wonderful, Mark. There's just so much material here. But I want to start off the Q&A session with giving first dibs to the students. So students, why don't you, if you have any questions, please unmute yourself, introduce yourself, and ask Mark questions. This is wonderful material here, so go for it. Students, questions.
I have a question. Hi, Mark. Thank you so much for the presentation, even with the time difference. That was really interesting and I really appreciated it. My name is Selena. I'm part of the ESE program, and I'm just wondering is there any chance that all of this might be an overshoot with the growth of AI? Is there any chance that we might hit a wall where we wouldn't expect, and it might change the trajectory of how much demand and things it can do we expect.
Yeah, it's a great question, Selena. And it's one of the reasons that we throw that slide in, looking at, where we over invested in fiber infrastructure for, as it's a great example. We ended up with companies going out of business because they couldn't sell that fiber capacity fast enough, and we had dark fiber all over the place. And yet the end value of all that investment in fiber infrastructure is what has facilitated, the dramatic growth in digital companies and a digital society, and we become dependent on it for everything that we do. And I think that most of us at EPRI anyway, and feel like we're gonna see the same kind of thing happen. This is really is a complete culture shift and revolution that it will result in a new way that society operates. And there'll be new jobs and new things that come up, but it will be completely dependent on this AI infrastructure. And but it probably, it will look like too much at some point. It look like we're like we've overinvested, and whether we need as many AI companies building these hyperscaler data centers, or it'll shake out to two or three of them. That's a good question, and there could be some dark data centers in the process. But in the long run, we'll take advantage of that infrastructure and really need it.
Okay, thank you.
Okay, thank you. Questions from students? Please unmute yourself, introduce yourself.
Hi, Mark. My name is Bintusila. I'm an ESE student. Thank you for your presentation. You mentioned a lot of cases where data center unplugged themselves, where frequency were oscillating too much. Do you think that there are some ongoing discussion where data center are planning to install some behind the meter frequency regulation that can respond in a timely manner instead of unplugging themselves and disturbing the grid?
Yeah, that's a very good question in terms of participating in grid management, whether it's frequency regulation or other aspects of stability, improvement. And I don't know how that will fall out, but it's one of the things that we're looking at in DC Flex. I think one aspect that we're going to see is that the investment in data centers in significant energy storage capability as part of being able to ride through voltage sags and have a more stable operation, maybe for training data centers, result in a smoother load to the grid than dramatically, dynamic loads. Storage really can be a big part of that, and investments in energy storage can be used during normal grid connection to provide benefits to the grid as well. And so I think rather than having um, innovative ways of actually controlling the compute power, or the computing process, or the data center processes themselves, I'm suspecting there will be investments in peripheral technologies like energy storage and power electronics that can be used to help the grid, as well as making the data center look like a better load. It's a good question.
Questions for Mark from students? Please unmute and introduce yourself. Questions from students?
Oh, yeah. Hello, Mark. Thank you for the presentation. My name is Panashe. I'm part of the ESE program. So I get that the AI is used in grid management and enhancing the grid reliability, and some of them machine learning is used to reduce power flows to enhance the grid stability. But looking at like this a chart that you once put up, it looks like the scaling of AI is growing faster than scaling the energy generation. So, based on those, do you think by the time, like when we get to 2035, the generation methods or storage that will be there will be able to sustain all the AI, considering the rapid movement that we are on?
Yeah, I think that the important thing there, that's a great question, thank you, is that it really, most of these large load regulations that we're seeing now are really requiring data centers to identify the generation resources that are going to be able to supply that data center load. And that really should include, resources like energy storage that's required to make sure that that the data center is a good citizen on the grid as well. But like the Irish example where data centers are required to, identify the generation that's either on site or nearby that can supply that generation load and make sure that they're investing in or supporting the investment in new renewables for the overall grid. Um, Kind of that's designed to make sure that they don't impact the rest of the ratepayers negatively and that they don't impose an undue demand on the grid that it makes a significant additional requirement on them that they need to come up with the generation and make deals for that generation and that's where a lot of the creativity is happening in terms of aligning the data centers with generation that's planned or available. How fast can you build gas plants? There's a Texas example where the Google data center has um, latched onto a large solar and wind installation that was already approved. So it could take advantage of that fact that it was already approved to start to go right into building their data center. Um, the it's putting the burden on the data center folks to make sure that the generation is there as well as the resources to be a good citizen.
All right, a follow-up on that. Based on that, it's bring your own generation for these data center companies, right? Or these big AI loads. Is there a regulation or policies that are being put in place in the US that requires every large load to bring their own generation or to connect behind the meter, or is something that is still being worked on?
Yeah, that's another good question. It's not part of the FERC regulation across the board. Um, the different utilities are coming up with different arrangements. They're coming up with contracts that might identify generation that's available somewhere else, but it has transmission capacity to get that generation to where the data center is being located. In some cases, they are behind the meter generation that's being built specifically for the data center. We're seeing the full range of possible structures in the US as it stands now. These new regulations are designed to help avoid ratepayer impact. So at least if there is additional grid infrastructure that's required as well as generation infrastructure, the idea is to kind of put that burden on the data center as well.
All right, thank you.
Thank
I
you.
have a question. Hi,
Hey,
Mark.
please,
Thank you. Hello, I have a question, Professor.
okay, please go ahead and identify yourself, please.
Okay, hi, Mark. My name is Yunus Kadzim. I'm also an ESE student. Thank you very much for your presentation. I was just wondering that we've been focusing on trying to build billions of dollars in transmission lines to move this power to data centers. Can't we just do workload shifting, just move the workloads to where there is already renewable oversupply? instead of trying to invest more money?
Yeah, that's another great question. I don't think there's any one answer, but I will say that there is a large push, from the data center folks themselves as well as the utilities to align where the data centers are to where the resources are. I know we see that here in Ireland as well, the concept of hosting capacity, of having capacity someplace in the grid that is already available to supply additional load, that becomes a much more attractive place to put the data center and feasible place to do it in a shorter time frame than if we're already in a constrained part of the grid. So whether it's grid resources or generation resources, aligning data centers to where they can take advantage of the grid and the generation resources is a big priority of where they end up, and it will be even more so in the future,
Thank you,
whether
Mark.
it's whether it's behind the meter or connected to the grid.
Thank you. I also have another question. People have been talking about bring your own generation for data centers, and I was just wondering if the government is specifying what kind of generation, because I'm guessing at some point, if we don't control that, we risk making AI dirty in the future. So is the government really telling data centers which kind of generation they expect them to bring?
That depends on where you are in the world, for sure. And the particular environment in the U.S. right now is not making the requirements that the generation be you know some kind of clean generation or even have the capability to move from gas to hydrogen or some other clean fuel in the future. But in other places in the world, there is an emphasis on move aligning the generation resources with decarbonization objectives. I will say that the investment and role of data centers in advancing nuclear technologies is really dramatic. I don't expect nuclear technologies to be a solution to any of these problems in the next 10 or 15 years, but the technology development is happening at a much faster pace than it would if we didn't have the investments and the commitments of some of these tech companies.
Okay, thank you.
Okay, any more questions from students? Okay, if not, the general audience, if you have any questions, please unmute yourself and ask questions. I do have some questions in the chat box, so I'll wait a few seconds before I switch to the chat box. Anybody with a question for Mark? Unmute yourself, ask us a question. Okay, we have a question in the chat box from David Ellis from PSE&G. He's referring to slide 17. Level E essentially demand response by a very large load. I guess this was where you had the categories of.
Yeah, that's David. That's exactly right. That category is the ability of the data center in some way, either with process management or with other resources like energy storage, to be able to look like a demand response resource. It's as simple as that. Good to see you, David.
Yeah, thank you for that. I guess the other question that came up a little bit later, you were talking about the energy agency talking about large loads and trying to influence that. Historically, we've had the regulation of load in the electric system be a state by state. And I was just wondering, are there different aspects of the large load question that are better suited for federal handling versus price setting that historically has happened at the state level?
Yeah, that is a really good question. And absolutely, this is something that's not been a federal consideration in the past. And maybe the unique characteristics of the very large loads makes them different. Although we have had large loads for forever, arc furnaces, aluminum plants, whatever, they still have always been managed and whatever regulations apply to them have been state, more state considerations than federal. So it's a new, I would say, power grab and on the part of FERC to be working in this space, and I love to see where that goes. I don't know the answer beyond that. It's a kind of a new thing, so it'll be interesting to see how it all falls out. If it's in terms of what it become actual requirements versus recommendations that the states can implement, or how it happens.
Thank you.
A question from Alexander. Has EPRI looked at how much the data center energy consumption is for cooling and what impacts improvements or more green methods would have with the demand and consumption of data centers?
Yeah, that's a great question. I don't have the numbers myself, but yes, we have a detailed look at the different components of data center load, whether, you know, and looking at even new technologies where the cooling occurs right at the chip level in terms of the increased efficiencies that you can be had from those kinds of technologies. And there's an effort to try to account for increased efficiency, which is dramatic and ongoing, but not keeping up with by any means with the increased demand for processing. So, but that's one of the reasons why when you make forecasts in this space, the ranges that you end up with are so wide. It's even though they're wide, even the lower end of the ranges are dramatic though. But yeah, the cooling aspect is absolutely critical and really keeping an eye on technology developments in that space from folks like NVIDIA that can really improve the performance and the efficiency needs to be taken into account.
All right. Question
I saw a
from
question about the report is on the public domain, so if you just, I think that you'll probably get the slides afterwards, but if you Google the Powering Intelligence report, I think it's poweringintelligence.epri.com. I think it has its own website.
Dan has another question in the chat box. Are you able to read that, Mark, or I can recite
Maybe
it?
not down that far yet. Is it the
Okay.
last 2018, 2019 time period?
Right. Yeah.
That's why I referenced that paper back in 2017. The question is, what was the big breakthrough in hardware and software that caused the explosive boom? But really, the breakthrough was in the the approach to training artificial intelligence engines and going from a training of word by word, looking at what word followed what word as we looked at what exists out there, and then being able to, when people did a query, essentially we were building responses by looking at what individual word was expected to, would likely occur after a previous word, to using this token concept, what we call transformer approach, where you're looking at large strings of data and words and information and relating every word to the entire string. So that word has a relationship to locations in that string and concepts in that string throughout. It could be whole paragraphs or whole books could be a string that we need to understand the relationship between that word and the rest of the words in that document. And that increased the required computing power to do the training dramatically, while also increasing the value of the results of that training dramatically. And that's when, the demand took off, like crazy to implement that technology, the transformer technology.
Okay. Questions for Mark? Okay,
Hi.
Kamal, go ahead.
Can you hear me?
Yep.
Yes.
Okay. My
And
question
see
is,
you.
these storage units, can they be built at colder climates, like close to North Pole? That will increase the cooling efficiency and plus to reduce the heat gains from outside. Is there any disadvantage of that?
Well, just for the cooling in general, those locations, cold climates, are definitely beneficial. You see that from Bitcoin miners for many years of locating their computing facilities for Bitcoin mining where they can save money on the cooling electric demand, and that applies to all aspects of artificial intelligence as well. The other thing that's valuable, we have an example plant here in Dublin, and I think there's other examples in the Netherlands. There's examples in the US as well of being able to take advantage as you're doing the cooling of the processing functions of the artificial intelligence, using the heat for other applications improves the overall efficiency of multiple processes. So, we have a data center in Dublin that provides heat for apartment complexes and a university complex that is adjacent to that data center. When you look at the efficiency overall between the data center and that apartment complex, it looks like it's more efficient because we're actually using that heat rather than just discharging it.
Thank you.
Okay. Question for Mark. Is here something in the chat box? What other data security are being considered to control data apart from data encryption and control data access with Open Power AI consortium?
Yeah, that's a really good question. I'm not, I really don't know the answer of in terms of specific technologies that are be using in terms of data security. A lot of what we're doing in Open Power AI, we're trying to focus on um, data that we can share in an open source manner and publicly available data. We have, you know, data security approaches that we've used for EPRI data that especially that relates to the nuclear industry and stuff that for many years and keeping it secure for applications that require that is being considered for AI applications in general. But in Open Power AI, in that particular collaboration, we're trying to focus on open approaches as much as possible. So data security is still critical, but there's also a focus on having using data and tools that are as widely available as possible so that security aspect doesn't become as critical.
Okay. Question from Michael Murphy. Michael, if you're still in the audience, please articulate your question because it's pretty. Michael?
Sure. At what level is integration, is the line drawn between simple programmatic processing of power distribution and artificial intelligence? For example, mechanically relays can be logically automated through any manner of devices, and we can even program them to some extent. But what level of these automated control structure defines it as AI in the power industry?
Yeah, that's a good question, and uh, it's it's a complicated one for sure, Michael. But one of the things that I'll mention with respect to that I think is very interesting and starts to blur the line a little bit is, Analog Devices has their innovation center. They call it the Catalyst Innovation Center here in Ireland. It's in Limerick, and touring some of the things that they're doing with at the chip level with distributed sensors and distributed intelligence further blurs that line. In other words, they're building, for instance, the chips that are being used in AMI 2.0 in the advanced metering systems that are going out, not in and being designed now. Those chips have basically, artificial intelligence type of processing on the chip, um, that can interface with more central processing units, but also has the capability to use large data locally and make decisions locally, maybe based on training that occurred on a broader level, but then downloaded in terms of the intelligence and the processing to local devices. So I think that, a smart relay or a smart switch, or a smart control in a load is going to become part of the infrastructure, and the dividing lines of where the training occurs for that intelligence, but where the intelligence actually operates is going to be interesting to see how that all falls out. I don't think there's a simple answer to the question, but I see intelligence being pushed out to the edges more and more.
Yeah, any last question from anybody? Uh, DC,
The
Dan,
question about data centers in Ireland is one that that EirGrid, the system operator in Ireland, is grappling with in a big way. The data centers are a little fighting back in terms of having to make significant additional investments. So, but at least new data centers are going to have ride-through requirements and requirements to be better citizens, to not impact the grid the way that kind of we've seen from a few events already for the existing data centers.
okay. All right. Thanks a lot, Mark. This is just terrific. Your talk and the questions and that you answered, and really benefited from quite a bit from your presentations. Well,
Thanks
thanks
a
a lot
lot.
again, Mark. Okay.
Appreciate everyone. Good to see you, Rudy. Thanks,
Good
everyone.
to see
Appreciate
you.
it.
Bye bye.
Take care.
You.
Bye bye.
You.